I know a guy who knows a guy. This can be a brief story of pointers, but how should we use them while programming and why? Any language has its own set of features which makes it the right choice for a certain group of problems and tasks. Golang has pointers like C and C++, but for example languages like JavaScript and Python don't have it. In the next couple of minutes, we're gonna talk about it. Well, each variable that you define takes a place in memory. For example, when you say a is clone equal to, for example, 15, in the memory, which is something like this, and all of these are rooms, a room is taken which has the value of a, which is 15. We talked about defining variables of almost all types in Golang in these videos. Check them out if you want to. Each room in the memory has an address. Now we have another type of variable, which is the pointer. So what does it do? So we have another row here, consider here, which is the address. And this one is the value. The b variable, which is a pointer to a, has the address of variable a. Let's define some addresses for it. For example, this one is the room 137, this is 138, and this is 139, and the last 140. Well, b states at some random place in the memory, for example here, and it is equal to 137, which is the address of a. Now, when we are coding and we want to work with the variable a, for example, change it, pass it to a function, whatever, we can simply ask b, and b tells us, I know a guy who knows a guy, and does whatever we ask for, even if we don't have access to the original variable. The other question is that, why should we use them? First off, let's see what happens if we don't use them. So let's get back to our example. Consider variable, for example, c, which is equal to a. Now what happens in the memory? In one other random place, for example, I was drawing it with black. For example, consider this is the room 1000. In the room 1000, we have an exact copy of the value a, which is 15. And they're not related at all. We don't want this exact copy all the time because it's a waste of memory and a little bit a waste of time. I mean, why store the same value multiple times? And besides that, if we want to change this variable, we have to update all of its copies, which makes it even worse. Most of the times, we don't use variables in just one block in our code. We use it in multiple blocks. One of the main situations when you deal with pointers is when passing a variable to a function, to whether pass itself, which is called pass by value, or a pointer to it, which is called pass by reference. You may have heard of these two expressions before. So let's get rid of this. Oh, it's too messy. Okay. For example, these are our lines of code. A is defined here. And this is a method call. Now we want to pass this to this function. So this function gets defined here, for example, in this place, and blah, 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 some codes here. And when a is called here, for example, it says that print a. Well, this a is not the same as this one, you know. This a acts as a c, for example, as another c. Let's show it with another color. There is a c, and they are not related in the memory. For example, if we draw something here, for example, a is here, and in some other random place there is C. Now if a change is applied to the variable C, the variable A will not be touched. Sometimes it's a good thing and sometimes it's not. Now let's code. I just wanted to show you two little examples of using pointers. The first one, let's delete all of this. And well, let's define a main function, which is func main. And here we define that A variable, which we talked about earlier, which is equal to 15. What does it say? Declared and not used. Okay, I know that. Then we define the B variable. We want this B variable to be a pointer to A. There are two characters needed for working with pointers. The first one is, let's comment this line. The first one is ampersand and the other one is the star. So how do we use them? If B is a pointer to A, we go for ampersand A. Now we suppose that B has the address of A variable. Now let's print B and see how it's look like. We go to terminal. What? I don't know what's wrong. Okay, let's open a terminal. Okay. Go run main.go. Okay, as you can see, this is the value of B. As you can see, it's a weird address. That's how addresses look like in memory. Okay, now let's see its use. Here, if we define a function, I want to show you the difference between using a pointer and not using a pointer. So let's define a function which increments A, which take a variable A at first just a simple variable, sorry. It takes A, which is int. And then it increases that variable. Okay. What does it say? Func is unused. Yeah, okay, we know that. Now let's do some prints. Okay, now let's see the difference. The value of A is never used. Okay. Do we care about it? I think not. Okay, let's see. Oh, sorry. Let me put some break line here. Okay, it says that we don't need this anymore. This B. Okay, it says that command line argument declared and not used. Okay, we don't use it for now, but we use it later. Okay, the initial value of A is 15 and the final value of A is still 15. So it means that this function did nothing. So how to fix that? So we define a pointer called B and we want to pass it here, but it does something for us which we don't want. We want to pass the whole pointer to it. We come here and put a pointer to it. Was this one or this one? Okay. The thing that you saw here is called referencing. Is when you put the address of a variable into another one, into a pointer typed variable. But we can do it vice versa and call it dereferencing. Dereferencing is like that. Here we get the address of a variable and we want to get to the value, update it and come back. So we have to dereference the variable. For dereferencing, we use the star variable. And we want to do it in the last place. And let's change it to B so it's more understandable. Now let's see the result. As you can see right now, the value of A is updated. Because in the first place, here when the value of A didn't change, we pass the variable to the function by value, but here we passed it with reference. So that's an example of the difference between using a pointer and not using the pointer. So let's have a quick recap. Ampersand is used for referencing, which means getting the address of a variable, and star character is used for dereferencing, which means to actually go to that address and get the value that the pointer variables points to. There is one other situation where you may see pointers a lot. Let's get back to our old discussion, which was defining objects. So let's delete this function and define a new object, for example, type person. A struct. Well, this struct has a name, which is a string. Should we add last name? No, forget about it. I want to add age, which is the variable which I want to work with, and it is int. So that if I want to define a method which increases the age by 1, which should be called every year, let's write that method. In the first place, assign it to the person, p person, increment the age by 1. And then we should pass nothing to it. We open it and we put like p age plus equals, do we have it? I don't remember it. P age plus 1. Now, okay, we don't need any of this. Let me instantiate this person class. P is equal to person. Does it have something to, well, name is, for example, parsa, which is me, and age, which is 26. I've just got 26, you know, my birthday was 2 weeks ago. Okay. We define this one. Now we have our object. Now, if we call p increment age by 1, and after that, we go for printing my age, in the normal situation, we expect that to see 27, but let's see what happens. As you can see, it is still 26, which is something which we don't want. So what do? Just like functions where we can pass variables to them by reference or by value, we can assign functions to structs by reference or by value. Here we assigned the method to the struct by value or something like that. They feel the same, so I use this term. But if you want to fix that, if you want to make a change to this struct, to a property of this struct, well, we have to use pointer type here. We have to put a star here. As you can see, our former warning has gone. Now let's check it out. 27. In the almost last step, I wanted to talk about the trade-off. Everything in engineering and life has a trade-off. Now we understood that pointers are efficient, they are performant, they can save some space, they can save us some times, but the flaw is that using them is so tricky and bug prone, so I'd rather not to use them unless I really need them. And by the way, if you're curious about Go and want to learn more, well, Golang is my first favorite language. I mean, it's beautiful. I'm creating a playlist about it, which you can see right up here. So far, I've talked about its basic syntax, how to define an object, which consists of structs and interface, and error handling. And this video, which you are in right now, is the fourth video, which is about pointers. This was it, guys. Thank you so much for watching. Hit the like button if this video might help you. Don't forget to subscribe. Be curious and keep learning.